Hello, I'm Kangyan, and today I will talk about advancing organoid research, the multi-camera array microscope for high-throughput 3D imaging and drug analysis. Organoids, which are 3D cellular structures that mimic the organization and function of organs, have become a powerful tool for answering a wide range of biological questions. They offer scientists insights into organ formation and disease and can be instrumental in drug discovery and personalized medicine. One common method for assessing organoid development is measuring their cross-sectional area through imaging, typically using a bright field microscope. A conventional microscope delivers high-quality images, yet it faces substantial limitations in high-throughput imaging. This is particularly problematic for large-scale experiments that need to image multiple organoids at once. Therefore, there is critical need for a high-throughput imaging system that can capture many organoids more quickly. Our lab has been developing a new multi-camera array microscope, which consists of multiple imaging sensors and lenses to rapidly image large field of view in a parallelized manner to address the challenges. The MCAM can image n times faster, which is the number of the cameras, than the traditional microscope by essentially decreasing the need for lateral scanning. Here, we tested two drugs, CHEER and VPA, and the CHEER, which enhances organoid growth, and the VPA, which inhibits organoid growth. The graph highlights the effect of CHEER and VPA treatments on organoids compared to the control group. All treated group showed a dose-dependent increase in organoid cross-sectional area. In contrast, BPA-treated groups experienced a significant dose-dependent reduction in the cross-sectional area. The MCAM's utility is not limited to bright field imaging, but can also perform fluorescence imaging. We scanned the entire 986 well plate for both bright field and fluorescence, demonstrating the MCAM's high throughput imaging capability with cellular resolution. In summary, MCAM can be adapted to accommodate different imaging needs, and rapid 3D imaging and analysis can be achieved at cellular resolution for organoid studies using the MCAM. Thank you very much.